Before we begin 11.6, I want to go back and review our terminology. So A of n is equal to our nth term. That is some random term somewhere in my sequence. And n is the number of terms. So if I give you A of n, it's somewhere maybe towards the beginning, maybe towards the end, maybe in the middle of this sequence. What our notation gives us is the ability to talk about subsequent terms in relation to A of n. So if the subscripting just tells me position, so this is A of n. If I go 1 to the right, it's A of n plus 1. If I go another step, it's A of n plus 2. If I go another step, it's A of n plus 3. If I go backwards with my sequence, I'm really talking about A of n minus 1 and A of n minus 2. Those subscripts are just giving me position relative to my starting point. So, for example, if I start with A of 7, you guys clearly know what comes next in the orders using your subscripts. But if you look, hopefully you can see if this is my starting point, then this becomes A of n plus 1. If this is A of n, n would be 7. 7 plus 1 is 8. This would be A of n plus 2. 7 plus 2 is 9. This would be A of n plus 3. In the same manner, if I go backwards, A of n minus 1 would be 6. A of n minus 2 would be 5. So now I can talk about every item in the series in relation to some key starting point. That starting point may be A of 1, it may be A of 10, it may be a random A of n. So, Fibonacci. Fibonacci is a famous mathematician who came up with this sequence. He started with 2 1s. If I add them together, I get 2. If I add 1 and 2, I get 3. If I add 2 and 3, I get 5. If I add 3 and 5, I get 8. So the pattern here is you're adding each term, each previous 2 terms, to get the next term. So 1, 2, 3, 4, 5, 6, 7. What is A of 8? Well, A of 8 would say take the previous 2 terms, add them together, and A of 8 becomes 21. So our formula to find A of n, whatever next term, would be to take A of n minus 2, 2 before it, plus A of n minus 1, 1 before it. And that's how we develop our sequence. So, for example, if we look at what we just did, example for A of 8, which we just found, we would take 8 minus 2, we would take whatever A of 6 is, plus 8 minus 1, A of 7. So A of 8 is 8 plus 13. So that's the way that series is going to work. Notice it's more complicated than just adding a constant d or just multiplying by a constant r. So we're going to talk about some special sequences here. Recursion is a key word, and that is where each term in the series is determined by one or more previous terms. And when you're doing recursion, we have to know the first term or terms so you can start the sequence. Then we'll go to the formula to generate the rest. So what does this look like? Find the first 5 terms. Here's my A1. Here's my formula. Notice that I have to start this at 1. Gives me a direction. So I have A of 1, A of 2, A of 3, A of 4, A of 5. First term's given to me, it's 5. Now what really does this formula say? It says the next term, A of n plus 1, is equal to 2 times the previous term plus 7, all the way across. So this term right here is 2 times 5 plus 7, which is 17. Now I'm at A3, so I'm going to use the previous term, 2 times 17 plus 5, which ends up being 41. Now I'm at the previous term, so now I take 2 times 41 plus 7, and I'm at 89. Previous term, 2 times 89 plus 7 is 185. So in the case of recursive formulas, you are always going to be given unique formulas every time. They're all going to have their own formula. It's not like the arithmetic or the geometric where we had a constant formula. The key is understanding what the notation means so you can use the right numbers. Now, we can also talk about iterations. And to iterate is a process of composing a function with itself repeatedly. So over and over. So you're using the same values over and over. This is function notation. It's going to work essentially the same as what we did before. Here we happen to be starting at x sub 0. It's the same thing as starting with 1, just a little bit different notation. And what this is saying, well, what is f of 5? Well, it's 3 times 5 minus 1. And so we have 14. Now to go from here, now my x is 14. So my formula says, well, what is f of 14? Well, it's when I take 3 times 14 minus 1, and I get 41. Now to go from here to here, my x is now 41. So I'm finding f of 41, which is 3 times 41 minus 1, which is 122. So all of the sequences in this section are going to depend on a previous value. So it's really a matter of substitution and work it out. Substitute and work it out. And that is the end of the lesson here.